So this is a new unit, key features of polynomials, and we are going to be talking about key features of different graphs. So the first key feature that we're discussing is domain and range. So domain simply means, in the most simplest form, all the possible x values. So you know in any graph we have an x and a y. And all those points, form a graph. So each one of those dots has an x value and has a y value. So the domain is all the x values, and the range is all the y's. Now, they're not just a series of points. They're not just a series of points. There's an infinite number of points, so it's hard to just list points out, but that's the basic idea. So if we look at this one, this is our basic parabola, and we want to state the domain and the range. So the first thing you have to remember is that the x values are this line. So when we're doing the domain, our values are coming from this line. And when we're doing the range, our values are coming from this line. So we almost pretend like, when we're doing the range, that the x values aren't even there. So what it's saying to us is, if I put -4 in, is there a value somewhere up here is there a y value? If there is, then the x value works. That's basically it. I know the domain is the x values, but they're all related, all put together in a sense. So if you look here, this is a regular parabola. This is just some basic parabola that I drew. We know that we can do anything. I can do f of 1. If I do f of 1, I get -3. If I do f of 5, I get 5. So these are all points. This is like 1, -3. This is 5, 5. But what happens if I put an 8 in? Will I get a value out? Like, I don't see it right here. There's no 8. But you see these arrows right here? These arrows, and it's not going straight up and down, or it's going out this way. Those arrow means that at some point, 8 will have a value. And at some point, all x values will have a value. So that's what these arrows mean. If the arrows weren't there, then the domain would just be all the x values that you can use here. But, sorry, I'm moving things around. But with this guy, the domain is all real numbers. So there's a few ways you can say this. It's all real numbers because I can't find a value where the graph doesn't exist, okay, for x's. So no matter what happens, if I put a value in for x, I will get a value out for y. So that means that the domain, and this is just notes, the domain is all real numbers. Any x value will work. Now we also do this in interval notation. So the interval notation looks like this, -infinity to +infinity. If you don't remember interval notation, we're going to have to go over it a little. But remember, if it's not in it, remember infinity is a concept, so we never actually reach it. So that's why we have regular parentheses and all real numbers. So it's going this way to -infinity and that way to +infinity. So then we look for the range. Okay, if we look up here, the range, what are the y values that work? So if you look here, there's no graph down here at all. So these y values don't exist in the graph. Starting here, remember we look at the y-axis for the range. So starting here, this is where the range starts. So it starts from here and it goes up forever. So it starts at -4, and any other value will appear in the graph. Okay, so the range starts at -4. Okay, now we do the square bracket because -4 is actually in the graph. Okay, if it was like an open circle, it wouldn't be. And then it goes to regular infinity. It goes up. It goes forever and ever. Okay? So this one over here, same idea. It's a parabola. So the domain is everything. Okay, because there isn't a value of x that I can't put in. There will always be a value of y when I put a value in for x. So negative infinity to positive infinity, or what's the other thing we can say? All real numbers, those kinds of things. So the range is your y values. So your y values, you always start low. So with the interval notation, what's the lowest point this graph reads? Well, it doesn't. It goes on forever. So the lowest point is, say negative infinity. The highest it reaches is the next number that goes here. The highest point is 5. So remember, I'm getting my values from the y-axis. Whoa! When I'm doing the range, I'm getting the values from here. Don't look at the x-axis. It doesn't exist. So the highest it reaches here is 5. The lowest it reaches is negative, and it has to go low to high. Okay, so let's look at another one. All right, so number 3. When we look at number 3 here, what's the domain? Is there any value where I'm missing an x? Is there any spot where the graph jumps or no? Okay, so in this particular one, the domain is everything. Okay, because if you look here, how wide, you also want to ask yourself, how wide does the graph get? Is there any spot in the graph that it skips? If none of that is true, well then it's everything. Okay, so this one, how low does it go? What's the lowest point? Well, the lowest point, the lowest point is negative infinity, and the highest point is positive. It's everything for this. There's no point that it stops getting low or stops going high. These arrows mean it goes on forever. Okay, so now we get to places, giving you an idea of different things you may see. So the x value, if I'm looking for the domain again. Okay, so what you're looking for is values are how wide the graph goes. Well, the graph keeps going forever and ever. And the graph keeps going this way forever and ever. The problem is this line. What does this line mean? Well, these two lines here are called asymptotes. And what they mean is that this graph is getting really, really, really close to that line, but it will never hit it. It's like it's a fraction because the denominator can't be 0. So that's where this comes from. But it doesn't matter. You're looking at the graph. This graph will never hit 2. And this graph will never hit 2. So every x value works. It goes on forever and it goes on forever except 2. So there's a couple ways we can write that. We say all reals. Oh, that's weird. All real numbers, but x cannot equal 2. Or we do a union of two things where we go x goes from negative infinity to 2 and positive 2 to regular infinity. So basically these parentheses mean that that 2 isn't not included and we union it. That's an or. So this stuff should have been reviewed, the interval notation and the ors. But if I have to go over it in class, I have to go over it in class. Okay? And then the range is how high and low it goes. Well, this thing goes down forever, and it goes up forever. Okay? So it's going to go from negative infinity to positive infinity. Is there any y value that it skips? Well, yeah, 1 is skipped. So it's going to look similar to this, but 1 is going to be skipped. So we can do two ways we can write it. So range is always the y, so it's all reals, but all real numbers. But y cannot be 1. Or we could just write negative infinity to 1, and we union it with 1 to infinity. So this is just, okay, basically saying it's everything but 1. Okay, because when we go up, everything is good. Everything. Oh no, I can't put a 1 in here. It's saying I will never be able to get a 1 as an answer. Okay, this one just like to put a couple funky things in there so you can kind of see. Now remember, open circles here and here mean this value is not on this part of the graph, and the open circle here means that's not on this part of the graph. If it was colored in or just solid in some way, then that value would be part of the graph. So this is very similar to the last one that we did. If we're doing the domain, if you're doing the domain, it's all values work. Just look at the x. If I put a -4 in, I'm going to have a value here. If I put a -2 in, the graph exists. If I put a 2 in, the graph exists. So that's what you're looking for. Is there any place, so this arrow's going on forever, that arrow's going that way forever. Here, is there any place we're skipping? Well, right here at x equals 0, you're skipping a value. So the domain is -infinity to 0, and combine it with +infinity to 0, or 0 to +infinity. Remember, it always has to go low to high, low value, high value, low value, high value. Or again, you could say all x's, or all real numbers where but x cannot equal 0. So remember, even though there's a little dot on these two spots, x is still in the same spot. X is still 0. Domain, I'm getting x values. Okay, and then the range. If you look here, so the range is going all the way down. Okay, so it's going forever and going up forever. We do have these dots, but am I really missing out on a y value? Okay, so if I look here, what's f of 1? Well, f of 1 is 1. F of 0, okay, I don't get a value. If I don't have an f of 0. But do I still have a y value there? So are all y values covered? Well, here there isn't a y value, but there is. So 1, remember I'm getting my numbers from the y-axis. So 1 doesn't have a value right here, but it's got one there. 0 for y doesn't have a value here, but it's got one there. So all the values of y are actually included. So the range for this guy is everything. There's no spot skipped. Every value of y is reached. Okay, so this one, slightly different, but gives you another idea. So the domain, is there any places that we skip? So this one's going on forever this way. Awesome. So we know it's going to -infinity. Where does it stop? Well, it stops right here at 2, or at -2. It's an open circle, so I put parentheses. And that combines with 0 to infinity, because x is 0 here, okay, but it's an open circle, so I put parentheses, and it goes on forever, so it's going to go on forever. And then the range, okay, so when we're doing the range is your y values. So we look down here. Okay, there's nothing down here. I got nothing, 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 nothing. Ooh, it almost starts here, but it's an open circle. So it almost starts at 1, but I'm going to give it a parenthesis because it doesn't really start. And then does it go up? Is there any value that skips? Gets skipped? Well, 0, 2 has got a value, 3's got a value. 2 has a value this way. It doesn't have one that way, but it doesn't matter. It has something. So those values work. So going up, that's your range. All right? I know it's awesome. See you tomorrow. Have a good day.